steps. I have gone ahead and mounted these servos into the frame as well. These servos here, essentially this servo here is obviously your rudder servo. This is becomes your either pitch or aileron servo, doesn't matter. And then you've got your elevator servo, your throttle servo, and your pitch or aileron servo on this side. So we've got 3 on this side, 2 servos on this side, all mounted into the frames using the appropriate spacers as per the manual, appropriate bolts. The other thing that I will mention at this stage is the fact that for these bolts that go through these servos into the carbon frames, I have not put the factory Compass servo nuts on the back side because they actually cut their own holes, they cut their own threads going through the carbon, and it's still very, very stable. It's almost like having a nut on there by default, and it's just more fiddling to get the nuts on the back, and at this stage I don't feel it's necessary. I've used this system on other birds before. They've never worked their way loose, but I will keep an eye on them, obviously. These are the cap head bolts, of course, that go through the frames. For this particular servo over here that takes the self-tapping screws, they're not as tight in the frame, so of course I've put the servo nuts on the back there. So there's only one servo that gets the self-tapping screws. I'll turn it around so you can see it. So on this side, it is the top servo. On this side, it gets the self-tapping screws, and I've put the servo nuts, the Compass servo nuts, what they call servo nuts, on the back side, retaining nuts, and that gets that portion of the manual done. The manual does show in step 7, it does show phasing control ring adjustment, and as I've said, I'm not going to do that just yet, simply because we don't know exactly where the swash plate's going to sit in the center of travel just yet until we get the servo linkages and everything set up to these bell cranks up here. So once that's all done, then we can set up the phasing. I can show you how to do that. It's very, very simple, and we can move on to the next steps in the manual. So I'll do those steps next, and then we'll come back and we'll talk about those. Thank you. Alright, we are back with the Compass 3D Plus build video. I just wanted to go over a couple of things that I did not cover in the last segment when we covered the engine installation, bottom plate installation, and fan shroud, clutch bell, clutch stack. All those issues I covered in a previous segment. However, there was a couple of things that I did not cover because I wasn't quite to that point in the manual yet, and I wasn't quite to that point in the build, but do bear mentioning. The first is the tank nipple. The tank nipple is a friction-based nipple. It doesn't have the screw tightening setup, compression setup in the bung that other helicopters do, and in fact I think from memory that the Knight 3D had. But in any case, it's basically a friction-based nipple, so if you give a pull on it, it will slide out of the hole in the tank, making access to the tank and clunk line easier. Getting the fuel tank out on Compass Nitro helicopters is very, very simple. It's one of the nicest designs I've ever seen in a tank insertion into the frame set. Basically, if you take this bracket off here that is at the base of the tank, 2 screws at the base, take that bracket off, the tank just slides straight out of the frames. There's notches in the frame for the nipples, and it'll slide straight out. So that makes it very, very easy. I don't like the clunk line included in any Nitro helicopter kit that I've ever built from any manufacturer, and that's Compass is no exception. I find the clunk line to be, it's nice and flexible, but I don't think it'll be incredibly robust and reliable. So I always put Hayes black neoprene clunk line in my fuel tanks, and I've done the same here. So I slid the tank out, I put the neoprene clunk line on and put it back in. Remember though that if you use Hayes, it does expand once it's been in fuel for a while. So you need to cut it a few millimeters short, 3 to 4 millimeters shorter than what you normally would, to allow for that expansion so that the fuel line doesn't hit the back of the tank and bind up. The other thing is that the tank is, as far as I can tell, identical to the Knight 3D tank, and which means that it does not have the hole in the tank is not large enough to fit either an OS bubbleless clunk nor a fuel magnet. I think a fuel magnet, if you grind down the end of it, the actual aluminium insert, you can get it through. But for now, I've gone with the stock clunk. What I did on my original Knight 3D is I actually drilled out the tank, I reamed it out so that it would fit a fit an OS bubble as clunk, which is what I prefer to use as my clunk, and I used a compression fitting to squeeze out the bung to take up the space. So I'm not exactly sure what I'm going to do with this tank yet, seeing as how the insert doesn't expand. I may have to leave it as is. I may have to go with a fuel magnet, which I don't really like because the foam tends to break down easily. But in any case, I'm running the stock clunk for now. We'll see how it goes. The other question, or the other subject I did not cover, was a governor. I will be running a governor. I will be running the Align governor. I almost always run the Aerospire MultiGov or MultiGov Pro, but with this bird I just got it as a package deal with the electronics, and the Align governor works very well, and it was very inexpensive, so that's the one I'm going to run. However, the fan on the 3D Plus is only drilled for one magnet. So if you use a magnet pickup with a Hall effect sensor, then what you'll have to do is you'll obviously have to either drill out the other side of the fan and install both magnets for balance issues, or you will have to put your entire clutch hub stack and fan stack onto a high point balancer after you insert your single magnet, as it's pre-drilled in the fan for a single magnet. So you'll have to rebalance that if you choose to go that route. What I'm going to do is I'm actually going to use the Spectrum backplate sensor. I've just recently received one of those. I have to cut the plug off and resolder a new plug on it that will fit the Align governor, and I haven't done that yet, so for now I'll be running off curves, but that's ultimately what I've decided to do for my governor sensor, because it's a lot of fiddling around to get this governor sensor mounted to the frame, and there is a hole built into the fan shroud so that if you mount a sensor to the frame, it can see down through the fan shroud and carbon plate there into that hole where the magnet is located in the fan. So if you choose to go that route, Compass have thought ahead for that, but I think that the old school system of using magnets and sensors and that is a bit outdated now. With the new backplate sensor, I'm hoping it just makes installation and setup a ton easier, so that's the way I'm going. The other thing that I need to touch on that I didn't touch in the previous section was that the engine screws in the soft mounting system, these small screws here that go straight through it, the dampening system is actually a two-piece mounting system with a bolt holding those two pieces together with a urethane dampener in the middle. Now, the urethane dampening is actually very soft on the 3D Plus, and the engine, if you move the engine, it can move a good 5 millimeters or 3 or 4 millimeters side to side. Now, it remains to be seen whether that causes alignment issues in the clutch stack and the clutch bell up against the pinion, if it causes excessive wear by rocking that clutch bell and pinion back and forth with the amount of flex that the soft mounting system allows. The soft mounting system on the old Knight 3D wasn't quite as soft. It was stiffer. It still provided dampening, but it was not nearly as flexible as this. So time will tell whether this extra flexibility causes problems in flight. I anticipate not, because this bird's been tested, but I want to find out for myself. Now, one thing to be very cautious of, I tried to tighten down this bolt that goes through the two pieces of the engine mounting block. I tried to tighten that down to compress that urethane a bit more to reduce some of that dampening effect. And this bolt strips very easily. Well, not the bolt itself, but the actual engine mounting bracket. The back side of it, it only grabs a millimeter or two of the aluminum or the aluminum out the back. And it is very, very easy to strip that bolt out, that M2 bolt. So be very, very careful. Leave those as they are tightened from the factory. I learned the hard way. I don't want you to have to learn the hard way. I actually, temporarily, for the time being, I had to actually use JB Weld on this bolt when I stuck it back in because it was easily stripped out. I will be getting a new engine mounting plate and everything to replace that, but for the time being, to get me in the air, I've stuck a bit of JB Weld on that bolt, and it's holding just fine. But just do be aware that aluminum is soft, and that it can strip easily, and that you cannot get any more compression out of it by tightening that bolt anyway, so there's no point in doing it. So that all goes along with the engine and fan and clutch installation and pipe installation. Pipe installation is very, very simple. It's just 2 bolts through the side, and I've gone with the GP Exhaust Energy 57 muffler, which is the new muffler design for the high displacement engines of today. The YS56, the NR57, and the OS55, and the OS55 is obviously what I'm running. So there it is. It's all mounted and ready to go, and I've actually maiden hovered this bird last night, and everything was running sweetly. So anyways, I just thought that those additional tips and tricks and gotchas would actually help you as you do the build, things to keep an eye on, and yeah, hopefully that helps.